The words of climate change, TF-IDF-based word clouds derived from climate change reports. Given the state of the Earth, many different kinds of reports, and other types of texts, on the topic of climate change are produced. We will here show word cloud-based visualizations for different types of reports on the topic of climate change. Word clouds is a frequently used method for visualizing the content associated with a text or a text collection. The most basic form of the word cloud displays words with a larger font the more frequently they occur, and then arranges the words in a cloud. Potential problems with the traditional word cloud include that a semantic interpretation of the word positioning might be inferred, also when no meaningful interpretation exists, and that font size as the sole indication of word significance might lead to longer words being perceived as more important. Still, easily interpretable visualizations of long texts can be useful, for example for raising interest in, or providing an overview of, the content of the text. We here aim to show and tell how we constructed such visual overviews of texts on the topic of climate change. Building on criticism of the traditional word clouds, we constructed word clouds with the following non-standard properties. Word prominences are determined by TF-IDF, term frequency and verse document frequency, instead of frequency. Prominence is not only indicated by font size, but also by the vertical position of the words and by bars with a height proportional to their TF-IDF values. The horizontal position of the words is determined by a one-dimensional TSNE visualization of word 2-vec vectors. We here exemplify our method for creating word clouds on the IPCC report, Climate Change 2021, the Physical Science Basis, Summary for Policymakers. Word prominences are determined by TF-IDF, term frequency and verse document frequency, instead of frequency. For background document frequency statistics, we used a small subset of the British national corpus. Prominence is not only indicated by font size, but also by the vertical position of the words and by bars with a height proportional to their TF-IDF values. The horizontal position of the words is determined by a one-dimensional TSNE visualization of word 2-vec vectors. Words with a similar meaning are therefore often positioned close to each other on the x-axis. The word sea is, for instance, positioned very close to the word ocean. Thereby, there is a meaningful interpretation of the positioning of the words on the x-axis, as well as on the y-axis. In addition, word prominence is not indicated solely by font size. We generated word clouds for different kinds of reports on climate change, written in or translated to Swedish. We here show the visualizations for two report types that are very different. A. Special reports on climate change and land, as well as on the ocean and cryosphere. And B. A report on thought structures that hinder climate change mitigation. The visualization for the special reports on climate change and land, as well as on the ocean and cryosphere. The word cloud for a report on thought structures that hinder climate change mitigation. Differences in the horizontal positioning of prominent words give an indication of differences between subgenres. For the first subgenre, there are many important words positioned on the right side of the x-axis, for example, desertification or sea level rise. For the second, there are many important words positioned on the left side of the x-axis, for example, problem, need, and seems. In the future, we plan to use the word clouds to visualize differences between documents over time, and visualize the coverage of a lexical resource over different text genres. Thank you for listening. The code for generating the word clouds is available at GitHub.